Hey everybody, welcome back and thanks for watching. In this chemistry lesson, we're talking about elements and the periodic table. Let's start with this question. You've probably heard of elements before, but what is an element? An element can be defined like this. It's a pure substance that cannot be broken down into other substances by ordinary chemical reaction. Each element has its own name and its own atomic structure. So here's an example. Gold is an element. You've probably heard of gold before. Every atom in a block of gold is almost exactly the same. It has the same atomic structure, and it can't really be changed into other elements by normal mechanisms. On the other hand, maybe you've heard of steel before. Steel is also a type of metal, but steel is not an element. Steel is the combination of elements, specifically the combination of iron and carbon. Everything that is matter is made of atoms, and every type of atom is a specific kind of element. There's actually 118 known elements. Let's practice drawing some of the most common elements in their atomic form. We'll start with a hydrogen atom. A hydrogen atom usually has one proton, sometimes has a neutron, and it will have one electron in its most common form. We'll start by drawing the nucleus of a hydrogen atom. Most hydrogen atoms have one proton and no neutrons, but for this example, we'll draw the hydrogen atom with a nucleus that includes one proton and one neutron. It has one electron, and we need to draw that in the first electron shell. So here we've drawn shell number 1, and we'll include one electron. So this is a hydrogen atom. You've probably drawn this atom already in this class, but you didn't know what it was called. Now you know that this is a hydrogen atom. This is the element hydrogen. And we know that specifically because of the number of protons in the nucleus. There are some things about an atom that can change without changing what the atom is. We could change the number of neutrons, but as long as there's one proton, it's still a hydrogen atom. We could change the number of electrons in this atom, but as long as there's still one proton, it's still a hydrogen atom. Let's draw the next element, and that is helium. Helium is different because it has two protons in the nucleus. So we'll begin by drawing the nucleus. We'll draw two protons, and we'll also include two neutrons. Those are the neutral particles in the nucleus. Not all helium atoms have exactly two neutrons, but most of them do, so that's why we'll draw it this way. Most helium atoms also have two electrons orbiting the nucleus. So we need to draw our first electron shell, and we need to include two electrons. Both of those electrons can go in shell number 1. You remember that our electron shells have a maximum. They have a limited number of electrons that they can contain. And for shell number 1, it's exactly 2. It can only hold 2 electrons, but for the helium atom, that's all that we need. So the helium atom, the one that we're drawing here, includes 2 protons. That's what makes it helium. It also includes 2 neutrons in the nucleus, and we're drawing 2 electrons in the first shell. Now let's draw 2 more elements. The third element is lithium. Lithium, you probably guessed, has 3 protons in the nucleus, and most of the time it also has 3 neutrons in the nucleus, and it'll have 3 electrons outside of the nucleus in the electron shells. So let's draw that. Lithium has 3 protons, which we've drawn here in the nucleus, as well as 3 neutrons, also drawn here in the nucleus. Now we need to draw our electrons. We'll draw shell number 1, and even though we need 3 total electrons, we can only put 2 total in shell number 1. So what do we do with the next electron? We have to draw shell number 2 and add that electron to shell number 2. So this is an example of a lithium atom. The main thing that makes it a lithium atom is that it has 3 protons in the nucleus. Just like we've said already, there's some things about an atom that can change. change. We could change the number of neutrons, and we could change the number of electrons. But as long as there's 3 protons in the nucleus, this is a lithium atom. Now let's draw the 4th element. This is beryllium. Beryllium has 4 protons in the nucleus. Sometimes it has 4 neutrons in the nucleus, and we'll draw 4 electrons. And we need to make sure and put all of these particles in the right place. So we'll begin by drawing the nucleus. We know that there are 4 protons, so those are the red spheres. We've drawn 4 red protons that have a positive charge, and we've also drawn the 4 neutrally charged neutrons. Now we need to place our electrons in the correct electron shells. We'll draw shell number 1, which we know can contain up to 2 electrons. So we've put 2 electrons in shell number 1, but we need to draw 2 more, and we can't just put them into shell number 1. Now we have to draw shell number 2 and place 2 more electrons out in shell number 2. So now we have a typical beryllium atom. A beryllium atom always has 4 protons in the nucleus. We could change the number of neutrons and we can change the number of electrons, but in order for us to draw a beryllium atom, we have to know that it has 4 protons in the nucleus. One of the really interesting things about these elements is they can all be organized into this big graph we call the periodic table. The periodic table is a visual way of organizing all of the elements. There are 118 known elements, and they're all here in this table. The arrangement of these elements is very intentional, so take notice of a few things. To start with, the elements are in order of increasing atomic number from left to right. So we have hydrogen on the top left corner, and then we go all the way to the right, and there's helium. It's a larger atom that has 2 protons in the nucleus. You might be wondering why the periodic table is not a perfect square or a perfect rectangle. These large gaps are there so that similar elements are in the same column. For example, the last column on the right includes the elements helium, neon, argon, and 4 other elements. These elements are put in the same column or the same group because they behave in similar ways. We'll talk more about that later. Also notice that each of these elements get their own square, their own box in the periodic table that includes some very important information. We'll use the element carbon as an example. Each element square includes the element name. So we're using carbon as an example. The name carbon is listed here at the bottom of the element square. Each element square also includes what we call the element symbol. The element symbol for carbon is C, and sometimes the element symbol is a very obvious abbreviation of the name. It makes sense that carbon is abbreviated with the letter C. The element hydrogen is abbreviated with the letter H. The element helium is abbreviated with the letters HE. But sometimes the symbol doesn't seem to correspond with the name at all. For example, the element potassium that starts with a P is given the symbol K. So why is that? Well, there's always a reason for this. In the case of potassium, the symbol K represents the word kalium, which was the original Latin name for the element. Included in the periodic table is also the atomic number within each element square. The atomic number is really, really important. I've already mentioned it a few times without giving you the definition. So here's the definition. The atomic number for each element is the number of protons in the nucleus. This number is what defines the identity of the atom. Hydrogen is always going to have exactly 1 proton in the nucleus, and so it has the atomic number 1. In this example of carbon, carbon will always have exactly 6 protons in the nucleus, so it's given the atomic number 6. Gold always has exactly 79 protons in the nucleus, so it's given an atomic number of 79. Each element square also includes what we call the atomic mass number. The atomic mass number is a little more confusing. The atomic mass number is the average number of the total protons and neutrons in the nucleus of the element. So even though the number of protons never changes for a given element, the number of neutrons can change. And that's why the atomic mass number is usually not an exact number. In the case of carbon, the atomic mass number is 12.011. So why is that? Well, it's because for most carbon atoms, there's exactly 6 protons and 6 neutrons. So that would give us 12, but some have fewer and a lot of them have more. So the average number of total protons and neutrons, which is called the atomic mass number for carbon, is 12.011. So it's slightly more than 12 on average. So now let's get some practice using the periodic table. Get your periodic table out and pause the video to answer these questions. After you're done, I'll give you the correct answers. Question number 1, the atomic number of nitrogen is 7. So that tells us that nitrogen always has exactly 7 protons in its nucleus. Question number 2, what is the atomic number of neon? The correct answer is 10. Once again, that tells us that neon will always have exactly 10 protons in the nucleus. If it has something other than 10 protons, then it's not neon. Question number 3, what is the atomic number of calcium? The correct answer is 20. That means that calcium always has 20 protons in the nucleus of the atom. Question number 4, what is the atomic number of iodine? The correct answer is 53. Again, that tells us that iodine always has exactly 53 protons in the nucleus. That's a lot of protons. The number of neutrons can change. The number of electrons can change. But if the number of protons changes, then it's a different element now. Here's another set of practice questions to get used to using the periodic table. Pause this video and try to answer these questions on your own. All right, here's the correct answers. Which element has an atomic number of 8? Looking at the periodic table, that's oxygen. What that means is that oxygen has 8 protons in the nucleus. Question 6, which element has an atomic number of 11? When you look at the periodic table, what we'll find is the correct answer is sodium. Sodium has an atomic number of 11, which means it has 11 protons in the nucleus. Question number 7, which element has an atomic number of 29? The correct answer is copper. Question number 8, which element has an atomic number of 118? The correct answer I'm abbreviating as OG, which is oganesson. Here's one more series of questions to help you use and learn the periodic table. Pause the video and try to answer these on your own. All right, question number 9, which element has the symbol B? The symbol B represents boron. Question number 10, which element has the symbol Ti? When you find that on the periodic table, you'll see that the element name is titanium. Maybe you've heard of that metal before. Question 11, which element has the symbol Ag? The correct answer is silver. And finally, question 12, which element has the symbol Pb? The correct answer is lead. I've always found that one interesting because Pb doesn't seem to correspond to lead at all, but there's always a reason for that. Let's do another set of questions. Pause the video and try to answer these on your own using the periodic table. All right, here's the correct answers. What is the symbol for gold? The symbol for gold is capital A, lowercase u. Number 14, what is the symbol for tungsten? The symbol for tungsten is W. What is the symbol for cesium? The correct answer is capital C, lowercase s. Number 16, what is the symbol for uranium? The correct answer is U. If you'd like a homework assignment, here's an exercise that I think would be really valuable to you. Memorize the element name, the symbol, and atomic number for elements 1 to 8, and then 4 more of your choosing. If there's an element on the periodic table that you're really interested in learning about, then put it down and memorize the name, the symbol, and the atomic number. Thanks for watching. If you have any questions or comments, feel free to post those in the comment section below. Thanks.